Hello, good morning. You should see the desktop now. I think that's okay. Can you hear me? Does everything seem okay? Whoop. Oh, I clicked on the wrong button again. Uh, there. Does everything seem okay? Do you see the desktop and can you hear me?
Yeah, we can.
Okay, good, thanks. I'm getting up some windows. Okay. All right. So first, I still haven't got the exam grades done. I'm almost done with them. I hope that I can have your exam grades up by this evening. Okay, so I'm almost done. Takes quite a while. So I'm hoping that by this evening that they'll be up. So look for your exam grades this evening. And like I mentioned a little while ago, when you do see the grades that are up there, look for your exam because I mark on your exam the points you got for each problem and mistakes you make. So you can see you can look at your exam, you can download it, you can read it on Brightplace or you can download it, but you can look at the exam and see how it's marked, just like in regular classes when you get exams back. So don't look just for the score. Look for the exam itself so you can see how you did. And also the other thing, some people ask me if when they see zeros for their scores, unfortunately Brightspace, when something hasn't been graded, it puts it down as 0 points. I think that's kind of dumb of them. It should show ungraded or not available or blank, but it shows zero. Okay, so if you see 0 points, it's more likely means that the exams haven't been graded yet. So I wish they would show something more intelligent than zero for a grade for an exam that hasn't been graded yet. Same with the homework assignments. It just shows zero until they get graded. Okay, so and the other thing is after you see your exams, if you have questions about them, please send me emails or come to office hours. So any kind of question you have about the exam is legitimate. How things was graded, how you were supposed to have done the problem, any comment that I made that you're not sure what I'm what I'm saying in the comment. So any kind of question at all about the exam, please ask. Okay. All right. So hopefully this evening, your grades for the exam will be up there. All right. Anybody got any question about stuff that we've done lately? Anything? Okay.
Nope.
Okay. Yeah. Today we're going to start talking about more, or we're going to keep on talking about loops, but we're going to do something that's kind of tricky. This idea, something called nested loops. Okay. And this is actually one of the more important things we do in the semester and one of the trickier things. So let me open up the Java visualizer. Okay. Now remember, actually go back a little bit. We talked about nested loops. See if I can find where we did that. I'm sorry. We talked about nested if statements. Okay. Oh, it's a while ago. And we're going to do something kind of similar. Okay. Um, Here. We have this idea of nested if statements. An if statement inside of an if statement. Okay. And you could put in nesting if statements was tricky because you could put an if statement inside the if part, or you could put an if statement inside the else part. And remember that the most important thing there was that this one is more important than that one. Okay, because that led to the else if idea. Okay, now we're going to take for loops and put for loops inside of for loops. Okay, so now we want to talk about nested for loops. Okay, now you can nest while loops too, but nested for loops are way more common. Okay, so if I just kind of mimic what I wrote over here, the idea is that it would look like something like this. Okay, I would say for. Now for loops got three parts. You initialize it, so you have some int I equal 0. Now here you have some. This is the start number. I less than the stop number, okay? And then you increment the number. So you have something, you go, I equals I plus increment. You increment by something, okay? So you have this thing that you might call a loop counter. So you have some start and some stop, and you increment it by something, okay? And then you have the body of the loop, okay? Now the key thing here now is to do this again. Inside here, put another for loop, okay? For something, okay? And there'll be the body of this for loop is another for loop, okay? Now in here, I'll say, now I need a variable in here that's going to count. See, this one counts from here to here by this much. Here, I'll use a letter J, and it's going to have its own. And here I'll say, this is what I do to start I. This is what I do to stop I. And this is what I want to do to increment I. And here I'll have, I need something to, a starting value for J, J less than the stopping value for J, and then I need to J equals J plus its increment value. Okay. Okay. So, and then do something. Now, what's interesting, how many times am I going to do this? Here's, yeah, think now, this is the hard part. How many times, do something, question mark, number of times. Okay. How many times am I going to do what I'm doing? Okay. If I just look at this guy, he starts at that number and stops at that number. So if we put in examples, for example, I start at 1 and go up to 5. Okay. Actually, and make it a little bit easier for now, put an equal sign in here. So I count and I'll increment by, oh, this was an underscore here, increment J. Let's just go up by 1. Okay. Okay. So we start at 1, go up to 5. So we count 1, 2, 3, 4, 5. So we did this thing 5 times. Okay. So this is done 5 times by that loop. Okay. Right. But now suppose I do some over here. Suppose I start here with 1 and go up to, say, 7 and increment this one by 1. Okay. This thing is done 7 times by this guy. Okay. So this guy does what's inside of it 7 times because it's counting up for each I. For I 1, 2, 3, 4, 5, 6, 7. It's saying do what's in here. Okay. Okay. So this blue thing right now gets done 7 times. But each time it's done, this thing says do what's inside here 5 times. So right now this is being done 7 times 5 times. Okay. So this is done 35 times. Okay. Okay. So and so nested for loops, a for loop counts, but a nested for loop multiplies. Okay. And that's the kind of it's that's one of the ways to think about this. That while this guy is counting and this one is counting, the nested part is multiplying. Because how many times do you do what's in here? However many times you counted here, but you do this counting over and over and over again. Okay. So like here we can do something real simple in here. System.out.println, and I'll print out J. Okay. Now notice I'm just printing J. Not I'll just print J. Okay. And if I visualize the execution, now just go to the end, see what it did. See how it printed out 1, 2. It printed out 1, 2, 3, 4, 5. That's what this guy does in here. He prints from 1 through 5. He did it one time, then there's 1, 2, 3, 4, 5 a second time. The second time is when this one said to do what's inside here the second time. Then when this thing is printed out 1, 2, 3, 4, 5, then it does it again because this one said to do print 1, 2, 3, 4, 5 a third time. Okay, so in here we're seeing the J go from 1 to 5, 1 to 5, 1 to 5, 1 to 5, while the I is going 1, 2, 3, 4, yeah, you get 5, 6, and there's the seventh time. Now, if you notice that there's 7 1s, 7 2, 7 3, 7 4, 7 5, 7 6, okay, 7 5, okay? So there's 35 numbers there, okay? So I actually printed 35 times, okay? And I can change those numbers a little bit, like I can like reverse them, put a 5 here and a 7 here, okay? This will print from 1 to 7, okay? But then it's told to print 1 to 7 by this one 5 times, okay? So this is also going to print out 35 numbers. It's like, again, it's doing, there's two ways to notice that there's two ways to multiply. You can say like 5 times 7 and 7 times 5. And you're taught that those are the same thing. 5 times 7 is 35, 7 times 5 is 35. But when you think of this as multiplication, it's not the same thing. 5 times 7 and 7 times 5 give you slightly different patterns down here. See, now I have 5 of the numbers 1 through 7. So I've got 5 of the numbers 1 through 7. There's the first of my numbers 1 through 7. There's the second one. There's the third one. There's the third one, fourth one, and then the fifth one. Okay. Here's kind of one way to think about it. I'm going to make a copy of this loop, and I'm going to use the copy 2 times. Okay. Okay. I'll make this one 7 and 5, and this one 5 and 7. Okay. And in between them, I want all of this to appear on one line, which it did, but I want all of this to appear on a second line. If I don't do something, this will end up after this one on the same line. So to get them on separate lines, I'll put a system.out.println in between them. Okay, that'll separate this guy. This one's output will end with a carriage return, go back to the beginning of the line thing, and then I'll start the beginning of a line here. Okay. Now, notice this prints 35 times. Okay, and this prints 35 times. Okay. Now this prints 35 times, which is equal to 7 outer loops times 5 inner loops. This one prints 35 times when it's 5 outer loops times 7 inner loops. So there's 7 of these 5-step inner loops. There's 5 of these 7-step inner loops. Okay. Now 7 times 5 is equal to 5 times 7, but as nested for loops, multiplication isn't the same thing. Okay. If I go here to the end and just look at the output, now you can see one of them went from 1 to 5, and it did that 7 times. The other one went from 1 to 7 and did that 5 times. Okay. Now, if you were teaching children multiplication tables, you could say, "Hey, look, look, there, you could think of a way to teach children where you're showing them that 5 times 7 equals 7 times 5, but they're really not the same thing. When you're taught that 5 times 7 is 7 times 5, that's not saying that this thing and this thing are exactly alike. They're just saying that they give you both 35 results. There's 35 things if you have 7 groups of 5 and you have 35 things if you have 5 groups of 7. And that's actually one of the ways you were taught to think about this. 7 groups of 5. 7's the outer loop. 5 is the inner loop. I have 7 outer repetitions of this inner loop. Here I have 5 outer repetitions of this inner loop. Okay, so this is 7 groups of 5, and this is 5 groups of 7. And in nested for loops, it makes a big difference. We're going to keep playing with these, and we're going to see that nested for loops, we think of them as kind of like a form of multiplication, because how many times does this thing do what's inside here? It's the product of however many times this thing works and how many times that thing works. Okay, all right. So this is what we're going to play with a lot: nested for loops. Okay, now let me show you what they're often used for. Okay, so I'm going to open up another Java visualizer. One of, not, and this isn't the only thing, but one of the real common uses of nested for loops is to print a table. Okay, so suppose I want to, here's how I would print a table. Okay, so what I'm going to do is I'm going to go up here and declare a variable, int rows equal, now make it say 4. I want a table with 4 rows, and I'll say I want so many columns. So int columns equal 5. So I want a table with 4 rows and 5 columns. Okay, so if I think of what I want, down here I can think of what my table is going to look like. I want a row 1, row 2, row 3, row 4, and row 5. So there's row 1, 2, 3, 4, 5. You can see the line numbers, 18, 19, 20, 21, 22. Okay, and then I want say 5 columns. Okay, so I'll just do something simple like 1, 2, 3, 4, 5 columns, and then another row 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So there's 4 rows with 5 columns. Okay, so you can think of that, this box is a table where that's the row, and then I've got a column going down. Okay, so how do I get this guy, the nested for? Now also notice that this is kind of a product. How many items are in the table? It's the number of rows times the number of columns tells me how many things are in the table. How many pound signs are there? There's 20 of them because there's 4 rows of 5, so there's 20 pound signs. So there's a multiplication there. Okay, what I'm going to do is this thing here, this outer loop is going to do the rows. When we generate tables and we do it with nested loops, this one prints this one does the rows. I should say this one doesn't do the rows. That's a bad way to put it. This one counts the rows. This one's going to count how many rows there are. Then this one will count how many columns there are. It counts the columns by doing each row. Okay, so this one, it's kind of fun. You can think of it as this one does a row. So this one counts columns, does each row. I'll put it this way. Okay, this one's going to go across a row. Okay, like here I will print just a pound sign. Okay, this one counts how, if I want to go across a row, I count column 1, column 2, column 3, column 4, column 5. So this one will go from 1 to however many columns there are. Okay, I'll count from 1 up to how many columns there are. And notice I can shorten this one by, if I'm just going to add 1 to J, it's usually common to shorten that by just writing J++. Same up here. If I'm going to just count by ones, it's a lot easier to just write I plus plus. Okay. So this is gonna count off the columns in one row. So counts the columns, does one row. It does one row. Okay. Okay. And up here, this one's going to count the rows. So this will be how many rows there are. 4 row 1, 4 row 2, 4 row 3, 4 row 4. Yeah, so I steps through the row 1, row 2, row 3. So I is choosing what row we're in, J is choosing what column we're in, and we're printing a pound sign each time. Okay? All right. So if I just run this, okay, there it goes. Oh, there's something wrong. It exceeded the number of steps. Okay? So something went wrong here. If I exceeded the number of steps, I shouldn't have, because there should only be 20 steps. Let's go to the end and see what we had. Okay. Now, okay, I printed a lot here. Okay. I made a mistake. What did I do? What did I do wrong here? Anybody see? Okay, okay, first of all, I wanted a table. Notice I got one long line. Okay, I didn't want one long line. I wanted a little table. Now that fixes, there's a trick to this. This was supposed to do one row, pound sign, pound sign, pound sign, pound sign, pound sign. When I got to the end of the row, which is when this loop is done, I want to go back to the beginning. So that means I need to change, I need to put a system.out.print line right there by itself. So that would say print the row, then go back to the beginning of the next row. Okay. So that will print one row and then go back to the beginning of the next row. So that loop combined with this thing will actually print one row. So now visualize it. Notice I'm still exceeding I'm doing too many loops. I'm not sure what I'm doing wrong. Okay. Now let's see. I've got a lot more rows than I wanted. What did I do wrong? Why do I get so many rows? I got my, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, but why did I get? Oh, I see what I'm doing wrong. Ooh, it's real subtle. I didn't quite erase enough things here. I wrote I equals I plus plus. Okay, I left a little when I was deleting the code, I left a little too much there. So it's that I'm not, that's you would never write a piece of code like that. Notice it's not wrong, but it's kind of weird to say what that thing's doing. Okay, so what I wanted was just increment I. Okay, so I wanted I to step from 1 up to rows by ones. Okay, okay, there's my little table. Okay, okay, I wanted 1, 2, 3, 1, 2, 3, 4, 5 rows, and I've got, oh, see, I have 4 rows. Oh, when I was talking, I wasn't counting. I want 4 rows. So I wrote 5 rows down here. Yeah. So I want 4 rows. 1, 2, 3, 1, 2, 3, 4 rows. And I want there to be 1, 2, 3, 4, 5 columns. So I was talking and then I drew the wrong thing down here. This many rows and this many columns. And that's what I get now. Okay. So I have something that can draw a little table. Okay. Now, if I change the number of rows, we'll see. I'll change the number of columns to 10. So that'll make these rows longer. See, Now I've got 10 columns, but still 4 rows. Okay. And I can change how many rows there are. I can say I want just 3 rows now. Go there. So there's 3 rows of 10 columns each. Okay. Okay. And now I'll make it look a little bit more like a table. Okay. Instead of just printing a pound sign, let me print out, well, let me print out what I is. Okay. Now if I print I, okay, now it looks a little bit more like a table. Though this looks like I'm printing the number like 1 billion, yeah, it looks like I'm printing the number 11111. So to make it look a little bit more like a table, what I'll do is I'll put space between, well, yeah, I want to put a space between that number and the next time I print that number. And I can do that by adding on just a space like that. Okay, so that'll convert this thing to the string that represents the number I and add to it the string that is one space. So that will print out I space. And then the next time it loops, it'll print the number, they'll print I again, but with a space to its right. At the end of the table, it'll put a space at the end of the table. At the end of each row, there'll be a space. That's okay. The last one has a space next to it. Okay. The last 2 has a space next to it. I don't really see them. I could see them, but instead of putting a space, put a period between the numbers. Suppose I put separate the numbers by a dot, or more common, a comma. Tables often have a comma between every column. Now, if I go here, I see there's a comma at the last number too. We'll see later how to get rid of that. Like if you wanted to print a nice little table, you might say, well, I don't want a comma at the end of the last row. There shouldn't be anything at the end of the row. So you have 1 comma, 1 comma, 1 comma, 1 comma, but there shouldn't be a comma after the last one. Okay. But notice I'm getting things that look a little bit more like tables. Now, with the comma, I probably want a space after the comma. Okay, see, starting to look more like a table. Now, notice now I now have a comma and a space after the last number, which I may not want those there, but they're okay for now. Okay. Now, instead of printing I could print J here. Okay. What's that going to do? What's my output going to look like? See, in words, how's that going to change the output? When this did 1 row, like it says here. Counts column does 1 row. 1 row, well, when I'm in here, I'm counting up the J's, but I is fixed. See, so I said I'm in row I, so I print I. Okay. What happens if I change that to a J? What does a row look like? When you do these loops, you have to think, the challenge in these loops is to think about what they're going to do. We're going to do this a lot. We're going to be asking, what will this do? Because we have to start thinking in terms of imagining in our head what this thing does. Okay. The outer loop says, do this many rows. The inner loop does 1 row. Okay. Outer loop says do this many rows. The inner loop does 1 row. When we think of tables, we think this way. This goes across the columns that go from the beginning to the end of the row. And this does the entries in the row. By putting a J here, what does each row do? What will I see down here if I just go to the end of the program and just see what it did? See? Each row counted up because here I'm counting the J from 1 up to the number of columns. So I'm counting up the J. So I count 1 up through 10, 1 up through 10, 1 up through 10, 3 times. Okay. Now that's different than before with the I. I'm saying I'm in the ith row. I'm in row 1, so I'm in row 2, I'm in row 3. Okay, like now here I can print out something a little bit more interesting. I'll print out both I and J. Okay, and here's how I'll print it in a way that looks nice. I'll print a little parenthesized pair, like ordered pairs, like in math. I'll say parentheses plus I. Then after the I will be comma space. Then I'll put plus J. And after the J, I'll put a closing parentheses and then another comma space. Okay. What that's going to do is it's going to print out that line is going to print out a pair. It'll print out something like this. It'll print out like the parentheses, number, comma, number, close parentheses, space, or well, comma, space. Okay, so print out parentheses, a number, I, which is what row I'm in. So this would be, I'm in the 3rd row, comma, space, make it easier to read by putting a comma space. Then J is, oh, I'm sorry, I is what row, yeah, and then what column I'm in. So I print out what row I'm in, then what column I'm in that row, okay? And then I print a closing parentheses and another comma. And then when it looped again, I'll print the next pair, which says what row I'm in, what column I'm in. So the next one here would be, I'm still in row 3, but now I'm in column 5. So we'll get something that looks like that. Okay. Now, if I look at the end, okay, see, I'm in row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4. These are like the ordered pairs in a math class in geometry. Like this tells me where I am in the table. Oh, right now, that's the 6th column, the 6th item in the 2nd row. This is the 8th item in the 3rd row. This is the 3rd item in the 1st row. Okay, they're coordinates. So yeah, I'm printing out a table and I'm keeping track of where I am in the table. Now, normally you don't want to print out where you are in the table. You want to fill the table with data or something. But this is letting me think about how this is working. It's letting me see that the I is choosing what row I'm in. Notice that the I is always 1 here. I'm in row 1, I'm in row 1, I'm in row 1. So while this loop is looping, I doesn't change. Okay. But this loop is the J. It's moving me across a row of the table, and I'm counting up J1, J2, J3, J4, up to J10. Okay. All right. So nested for loops can be thought of very much as like tables, and then I can change. I can have 4 columns and 2 rows. Okay, there's 4 columns and 2 rows. Now let's actually watch it execute. It's kind of let's watch it go through its steps. So if we start the program, the first thing we do is create the row variable. We keep track of how many rows there are. Notice that I could have just put a number 2 there. If I wanted to, I could go back here. Don't need those. I could say 2 rows and 4 columns. But that's not a good idea. That makes the code becomes harder to read and harder to change. You should say how many rows and columns there are, not just put it as raw numbers in like that. We call these magic numbers. When you have a number like that that just says, well, that's actually the number of rows, and this is really the number of columns. Those are kind of magic numbers. If this is the number of rows, you should name it that way. This is the number of rows. This thing here is the number of columns, and then give those things little names. Okay, so this is the better way to do it. So I say, and notice it makes it easier to change. If I want to change the number of columns, I just put it in one place. I mean, it was only one place here, but later on, if your program's printing out multiple tables of the same size, you may have you set the rows and the columns one time, and then you may have multiple loops to print it out multiple tables. So it's nice to have this in one place. Okay, so the first thing our program does is it says how many. We create a variable, how many rows there are. Create another variable, how many columns there are. Then we need a variable that's going to count in this loop from 1 to the number of rows. So now our loop's going to create a counter for itself. I is going to be the row counter. It's going to count. So when I is 3, it means we're in row 3. Okay. So, and then we initialized I to be 1. Okay. Now we check, is I less than, have we got to the last row yet? No, we haven't. So we're going to go into the loop. Okay, but now into the loop means we hit another loop. We're just starting this loop. So the first thing we do is we create a loop counter for this loop. Okay, so J is 1. Okay, now we create the loop counter. Now we're going to go to here, and is 1 less than columns? Yeah, 1 is less than 4, so we go into here. Okay. Now we're going to print out the first piece of data. Okay, then after we printed out the first piece of data, we go back up to here. Remember go back over here. We have our picture for a for loop. Where was it? We're going to be using this a lot. You come into a for loop there, then you do the test, then you do the body, then go back over here, do the increment, and then the loop looks like this: increment, test, body, increment, test, body. There's the loop. Then when test is false, then you leave. Okay. Okay. So we go from the body to the increment. J is about to become 2. Now we're at the test. We don't see it. See it. The visualizer shows us is staying on this line, but we just moved from the increment part of this line to the test part. Okay. So now we're going to test: is 2 less than 4? Is 2, the J, less than 4, the column? And the answer is yes. So we go from here to line 11. Okay, so now we're on line 11. So now we're going to print out the next tuple. Okay, so now we're in row 1, column 2. Okay, now after we did that, we went back up to this one. So now we're about to increment J to 3. Now we're back to this one. We have to test our loop again. Now we're in here. We print again. Okay. Okay. We just printed, so that means we're back over here. Okay. Now J is 4. Okay. Okay. Now J is less than 4 is less than or equal to 4. So this is still true because we have to do one more column. So this is still true. There's the 4th column. Okay. Now we're not done yet. See, we did that. Now we have to go increment J one more time. J is 5. Notice how J gets the loop ends when the counter is 1 more than it's supposed to be. So see, now we incremented J up to 5, and now we go over here and test it. Is 5 less than or equal to 4? The answer now is no. So now this one is no. So we jump to the this thing here, the thing that lets us, remember, we're sitting right at the end of this line. So now we jump to this one, which puts us at the beginning of the next line, which we won't see it in the output, but it's really putting us it's moving us from the end of this line to the beginning of that line. And then we go back up here to this for loop. Oh, notice how the J disappeared. I should have backed up. Let me back up. When I got to this print line, the J is gone. See, if I go back up here, right now I'm right there. I've got J5. I'm testing whether J is less than or equal to 4. This is false, so I jump down to 13. But when I leave that loop, real important to remember, when you leave that loop, the J goes away with it. So step forward, I left the loop and J disappeared. Okay, I print out the blank line. go to the beginning of the next line. Now I'm at this loop. Where am I? I'm right there. I finished one iteration of the outer loop, and now I need to increment I to 2. I just finished row 1. I'm about to do row 2. Now I'm here to ask, have I finished doing the rows yet? Is 2 less than 2? Yes. This is 2 less than or equal to 2? Yes, it is. So this is true. So I go back in here, and now I'm restarting this loop. See, now the trick is that this loop starts back up again. Every time this thing is true, you go in here and you do what's inside this loop. That means you have to start up this loop. So now I'm right here. So I have to create a new J. This is a new J. It's not the old J. Okay, so there's my new J. It starts off at 1. Now I'm here. Has J got to 4 yet? No, it hasn't. So now I can go into the line 11. And now I'm ready to print out one of these pairs, but I'm at the beginning of the second line. So I print out row 2, column 1. Okay. Now I just printed out 11. So I'm over here, about to increment J. So J is now 2. Now I'm here. Have I reached the end of the line? No. So I go back inside here, print out another pair, increment J to 3, test J. It's still true. So I print out another pair. Okay. Now I'm back here. Remember the loop, here to here to here, here to here to here. So I'm over here now in the loop. I'm about to make J go up to 4. Is 4 less than or equal to 4? Yes. So I go back in, got one more pair to print that last pair. Okay. Okay, now I'm back over here. I went from here to print to J++. Now I increment J to 5. Okay, J is 5, but now I'm back here. Is 5 less than or equal to 4? Now this one's false, so I'm down to here. Oh, notice that J disappeared again. I lost my second J. Okay. Now I print out this print line, and now I'm back up here, and I'm in this thing here. I'm about to increment I to 3. Okay, so I increments to 3. Now, is 3 less than or equal to 2? This thing is false now. So now I'm going to jump down to the end of the program. Okay, this one's false. I'm going to jump down to the end of the program, and notice that my I disappeared now. I finally lost the I because I'm no longer in this loop either. This loop, now the nested loops are done. I'm at the end of the program. Okay, and there's my output. Okay, so we watch the whole thing work out. Notice how every time you start here, when you iterate this thing, you have to start a new inner loop. So that means you create a new J for each one of these loops inside here. So J starts at 1, you get a new J each time, then this thing loops to its end, then J disappears when you get to here. You go back up here, and then you increment I. If this thing's true, you go back in here and create a new J that starts off at 1 again. Okay. All right. So there's an example of something that actually prints out a table. Okay. So no second. If I want to, I can take this. I'm going to copy it and go back over here and make a record. See, that's what this thing prints out now. That. Okay. So that's the table that this thing prints out. Okay. Now, if I want to change, I can change the number of rows and columns by doing these things here. Okay. Now let's do more examples. Now there's lots of things you can do with nested for loops. Okay, let me copy and paste this into another Java visualizer. I'm going to copy and paste this, but I'm going to then change the loops to do something a little bit different. Okay, so there's my nested for loop. Now let's see. Instead of doing what's in here, I'm going to change something a little bit. I'm just going to print out, I'll go back to just printing out J. Okay. That's going to count up from 1 to this number in each row. But I'm going to change this thing. I'm going to change this thing here to say print. Okay, I changed. Instead of doing print line, I'm saying print vertical bar. Okay, now what's that going to do? Let's try to think it through it. Okay, the answer is not going to be a table this time. It's not. It's going to be. It's still nested for loops, but it's not going to be a table. Okay, this is going to say do something 2 times. So that's saying do something 2 times because I goes 1, I goes from 1 to 2. So I starts at 1 and counts up to 2. So I do 1, 2, 2 times. What do I do each time? This thing says count up from 1 to columns, and it prints out the numbers from 1 to columns. So it prints out J, columns is 4, so it prints out 1, 2, 3, 4, 1, 2, 3, 4. So this thing prints out 1, 2, 3, 4. But after it's printed out 1, 2, 3, 4 on a line, it just prints a vertical bar. Then it goes back up here and does the next. So what it's going to do is all on one line, it's going to print up 1, 2, 3, 4, bar, 1, 2, 3, 4, bar, 1, 2, 3, 4. So at the ending result is going to be a single line, but with bars between the, see, 1, 2, 3, 4, bar, 1, 2, 3, 4, bar. Okay. It's not really a table, but it is nested loops. There was the first iteration of the inner loop. There was the second iteration of the inner loop. Okay. And I could, change the number of rows to say 3 and the number of columns to 5. Okay. Now I'm printing out, I'm not printing out 15 numbers because there's 3 loops of 5, but then there's these little bars between them. So I'm not printing out 15 numbers, but I'm doing this thing 15 times, doing this thing 15 times, and doing this one row number of times, 3 times. So I'm going to actually print out 18 numbers, 18 symbols. Okay. Count up to 5, vertical bar, that's one loop. Count up to 5, vertical bar, it's another loop. Count up to 5, vertical bars, another loop. Okay, so I did 3 groups of 5. Okay, outer loop was 3 groups of, and this was 5, well, 6 really if you count the extra bar. So it's 3 groups of 6. Okay, so this prints out 6 characters, and there's 3 groups of them. Okay, so it's multiplication still. It's 3 groups of this, but in this case, all on one line. So nested for loops, they're only going to give you tables if after the inner loop, you remember to print out, like if I change this to print line, now it's going to print the vertical bar at the end of each row, but start another row. So I'm going to be back to being table-like, but I've got a vertical bar at the end of each row. And if I think that looks nice, I could say, well, why don't I put a vertical bar at the beginning of each row too? So at the beginning of a row, I would put something, there's something to put at the beginning of the row. But if I wanted to begin the row, I shouldn't put the LN there, because if I put the LN there, watch what this one's going to do. See, it was at the beginning of a row, but then I said print line, so I went to the beginning of another line, which isn't really what I wanted. I wanted this to be one row. I wanted something at the beginning of the row and at the end of the row. So to put it at the beginning of the row, I think, oh, just print here. Okay. So now if I think of this as doing a table, before the for loop, I can put something at the beginning of each line. After the for loop, I can put something at the end of each line. But I need a little print line here to make it go back to the beginning of the next line. Okay. So I can think of that as a table. Okay. All right. And if I wanted to, of course, I could put something different at the beginning. I could put let's see, I'll put a pound sign at the, well, I'll put a vertical bar at the beginning and a pound sign at the end. So I don't have to have the same thing at the beginning and end. So I can create, this is actually how tables, when you see tables in data, this is essentially what you're seeing everywhere in the world. When you see tables of data, you're seeing nested for loops. If a computer prints a table, it is almost always going to be done with a thing like this, some kind of nested for loop that'll print out the table. If I want that to look a little bit prettier, I can go back to putting the plus, comma, space after each number. Okay, looks a little bit nicer, look a little bit more table-like. Notice that this thing kind of is messing me up. That really, I want the comma space between those, but I don't want the comma space there. Okay, well, let's think about how we can get rid of that. If I'm in the first column, I want the comma space. If I'm in the second column, I want the comma space. If I'm in the third column, yes. If I'm in the fourth column, I want the comma space. If I'm in the last column, I don't want that. Notice that there's an if there. So I can use an if statement to fix this little problem. Okay, so I'm going to go over here and I'm going to say, I'm going to do something like this. If I'm in a column that's strictly less than how many columns there are, okay, if I'm in a column where I'm strictly less than how many columns there are, then I want the comma. But else, well, now I know I'm in the last column. So then I would just say, print this without the stuff at the end, without the comma space. Okay, so let's see. So I'm gonna now things start looking. It unfortunately gets harder to read. I want to solve a little problem, but I solved the little problem by more code that makes things a little bit trickier to read. I want to print out one row, but now I've got something that says, well, it depends on where in the row I'm at. If I'm not yet at the end of the row, print the number with a comma after it. But if I have got to the end of the row, so I can put a little comment here to help read. It's at the end of the row. I'm at the end of a row here. If I'm at the end of the row, I print the number without anything after it. Okay. Oh, see, looks nicer now. Okay. If I want, I can go back to putting the vertical bar there, and the row and kind of each row kind of begins and ends in the same way now. Okay. Okay. And now you can, well, maybe you want a space after that last number, but not the comma. Okay. So for example, I could go here and say, oh, I want a space after that, but not the comma. I think, maybe I think this is going to look better that way. Okay. Okay. So, maybe I think it looks better that way. And then I think, oh, maybe I should have a space. Maybe I should have a space at the beginning too. Okay. I can do that really easy just by putting a space there. At the beginning of each row, put a vertical bar space. There. Okay. Kind of nice. There's kind of a nicely formatted table. Okay. All right. So now, but notice that when you start wanting to make things look nice, you have to write extra code. You have to put, I needed to put logic in there. I needed something that says I either am at the end of, I'm not at the end of a row yet, or I have gotten to the end of a row. So I needed something to tell me where I was. Okay. Okay. Now, again, if I do this, that's something simple. I mean, look at what's going to look like now. I'm just printing out one row, but now kind of, if you think about this one now, I don't want double thingies here. I don't want a double thingy here. I don't want a double thingy here. I want to be just one thing there. But now, okay, suppose I want to print out, vertical bar 1, 2, 3, 4, 5, vertical bar 1, 2, 3, 4, 5, vertical bar 1, 2, 3, 4, 5, vertical bar. This is a little bit tricky again. I have to think of some real logic. There's 2 vertical bars there, and I only want one of them. One came from the end of that line, and one came from the end of that beginning of that line. I need to get rid of one of them. Okay, so I need to get rid of one of them. Well, if I get rid of this one, that's not really what I want to do. Because now I lost my vertical bar at the very beginning. Okay. On the other hand, if I get rid of this vertical bar, which is the end of each row, that's not going to quite work for me either. Because now I don't have a vertical bar at the very end. But I can fix that kind of easily by, at the very, very, very end of both loops, I could say just print a vertical bar. So that would fix the problem. So I could get rid of the vertical bar at the end of each row and leave the one at the beginning of each one, and then put a vertical bar at the very end. Okay, see? So vertical bar 1, 2, 3, 4, 5, space, vertical bar 1, 2, 3, 4, 5, space, vertical bar 1, 2, 3, 4, 5. Okay, notice that I'm playing games with trying to output things. And this is what we do with nested for loops. I'm working with groups. Each group is the inner loop that are repeated. See? So I've got that group repeated again, repeated again. Oh, and then I got this little guy at the end by himself. But it's so the nested for loops are up to here, and then there was this one thing at the end. Okay. Right. So I mean, and I've got something now that that might be a useful kind of output. It prints out kind of a nice pattern. Okay. And if I want, I could change what is the symbol that's separating them. Okay. All right. So nested for loops work in groups. Whenever you have to do something where you've got groups of things, okay, the outer loop says do the inner loop so many times. Okay. So a lot of times, if it's tables, we think of this as rows and columns. Okay, but we just saw that it doesn't have to be tables. It doesn't have to be, I'm printing out tables. I can, in this case, I'm printing out one row. It's not a table. Okay, so the output in this case, that's what I'm printing out. But it's still, I mean, if I showed you this, now this is what we'll do, like with problems. When we start doing problems, I'll show you that and say, write the code that would do this. Okay, and you'd look at that and think, but there's a pattern of groups. There's, it wouldn't leap out at you that this is nested for loops. But you have to start thinking. You say, well, I see that this thing looks like that thing, which looks like that thing. So I've done something, the same thing 3 times. Okay, so I need a loop that does something 3 times. But then what does the loop do? Well, the loop prints out numbers going up from 1 to 5, so that would be a loop inside of a loop. My outer loop says 3 times do 1, 2, 3 things, kind of repeated. And then I think, well, what am I repeating? I'm repeating printing of a number. Well, I print a bar, and then I print out numbers up through 5. Okay, that's one group, bar, numbers up through 5. Then the next group is bar, numbers up through 5. So the bar, numbers up through 5 is the inner loop. Okay, that's the inner loop. So you think of you have to come up with the idea that this is nested for loops. When someone shows you a table, it becomes kind of obvious. Most books use tables to introduce nested for loops because then there's, print one row, print one row. So the outer loop is doing the rows and the inner loop is doing columns. Oh, one important idea is you could imagine that you would print a column, then print a column, then print a column, then print a column. And in fact, in computer graphics, you can do these tables by printing columns. Because in a computer graphics environment, you can print vertically. You can print going down. Like you could print that parentheses followed by that one below it. Then you can go back up and print out that one. Then you can print the two below it. You can't do that with system.out.println. System.println forces you to go across a page from left to right. Okay, it forces you to write like you do in handwriting. You have to print across a line. Then when you're done with the line, you go back to the beginning of the next line and print across the line. But in computer graphics, you can actually do this quite differently. In computer graphics, you can write for loops that go down a column. So you could go, this could be the column loop, and then this would print out all the rows in a column. But you can't do that with prints. Okay, with prints, this has to be the rows, and this prints out everything in a row. But with computer graphics, this could pick a column, and this could print out everything in that column. And we force you to think one way when there's nothing in the for loops that says it has to be that way. The thing that says this has to be a row and this has to be what's in the row is because we're using prints. Prints only go across. There's no way to go down in a print. But in computer graphics, there's other ways of doing output besides print. If you have graphics commands, you could go down, up and down row columns instead of going always across row. And notice that I have to go from top row to bottom row. I can't work my way up either. In computer graphics, I could print the bottom row, then move up and print the next row, then move up and print the next row. I could print rows from bottom up. In a computer graphics one, I could print that, and I could actually print rows from right to left. So in a computer graphics, I could print that row from right to left. Then I could print that row from right to left. Then I could go up, and I can go from right to left. I can go down from left to right. Computer graphics gives you a lot more freedom. Printline doesn't. No freedom at all. It's got to be from top to bottom, left to right. Okay. So when you see tables or lines of output like this, when we're doing simple programming like this, you have to remember that it's going to be top to bottom. It's going to be top to bottom, left to right. So this one was top to bottom, left to right. Okay, it's got to be that way. Okay. Now, and if it's a table, it kind of leaps out at you nested for loops. Outer loop does rows, inner loop does columns. When it looks like this, it doesn't leap out at you that that's a nested for loop. Yeah, you might have to think a little bit harder to realize that this one is going to be a nested for loop. So you have to say pattern within a pattern. Repeat a pattern that gets repeated. Okay, so the thing that's being repeated is the inner loop. So that's the inner loop. And then the outer loop is saying repeat it, repeat it, repeat it. Okay, so the inner loop is the thing that's being repeated is the inner loop, and the outer loop is doing the repeating. If you think of it something like this, where it's not a table, so it's maybe not so obvious that it's nested for loops. Nested for loops can be really hard. I can give you some of the most challenging problems you can find in programming books are in the nested for loop section. You can create some of the hardest problems we know in things that involve nested for loops. It requires a pretty sophisticated way of thinking to think in terms of repeating patterns. Pattern that gets repeated. Then figure out what's in each pattern. How many times find the pattern that's been repeated. How many times does it get repeated? Notice that in this case, this guy here was off by himself. Notice that there's a little subtlety that this one was not part of the pattern. So the pattern was vertical bar 1 through 5. vertical bar, 1 through 5, vertical bar, 1 through 5, and that closing vertical bar, I just threw it in at the end by itself. So it wasn't part of the pattern. See, so sometimes you'll have to see a pattern. Oh, and I can actually do this same output a different way. Instead of putting this vertical bar on its own at the end, I could have the pattern be 1, 2, 3, 4, 5 vertical bar, 1, 2, 3, 4, 5 vertical bar, 1, 2, 3, 4, 5 vertical bar, and then have this guy off by himself at the beginning. So let me show you, like I can comment out that one. No, comment out that one, put that one back, and take one of these and put it at the very beginning. Okay? Notice I made a lot of changes. I made 3 changes. I commented out that, put this back in, and put this one in. And I'm going to get the exact same output. Oh, no, I didn't. Oh, I have to make one more change. I think I forgot to comment out. I have to comment out. I have to comment out this one. Okay? I have to comment out that one. See? One by itself at the beginning. That's this one. Now the pattern is count up to 5 vertical bar. So count up to 5 vertical bar. Count up to 5, then print the vertical bar. And do that over and over again. So one vertical bar by itself, then count up to 5 with the vertical bar at the end. Okay, visualize. Okay, there's my output. Okay, but it still didn't not quite right. Okay, if I compare that, see, I had a space here. See, I had a space here. Now I lost that space. Okay, I can fix that. The pattern is count up, then vertical bar. But now I see that I need that vertical bar to put a space after it. So the pattern is count up, then a vertical bar with a space after it. So count up, that's the inner loop, count up, vertical bar with a space after it. Okay, now check it again. Look, okay, almost what I wanted, but I needed a space at the beginning too. See, that vertical bar had a space, so I want to put that space back there. So now I can go here and say that one needed a space too. All right. Okay. Now I've got the exact same output. Okay. So, but now look at the code. I could either I could have this one with this one, or I could have put this one, I could comment out this one and put this one back in, and comment out this one and put this one back in. Because if I look at this pattern, I can see it 2 ways. The pattern is count up to 5 with a bar space, count up to 5 with a bar space at the end, count up to 5 with a bar space at the end. Or I can see the pattern as bar space count up to 5, bar space count up to 5, bar space count up to 5, with one vertical bar at the end by itself. The second way has the vertical bar by its space at the end. One way has a vertical bar by itself at the beginning. Okay, so if I tell you to do this, it's a nested for loop, but there's multiple ways to see that pattern. You know, depending on how you want to think about it as, do you want the pattern to be that, or do you want the pattern to be that? Notice that they kind of, you can break it up into kind of like 2 overlapping patterns. Okay, it's either that thing gets repeated, or it's this thing that gets repeated. Not easy. You know, these things can be very tricky. And also now you can start seeing that I can give you a problem involving nested for loops, and different people can solve it different ways. Someone can look at that and see 2 different patterns there, 2 different ways of getting to this. Again, you know, repeat that thing there, 3 times, or now repeat that thing there 3 times with a little thingy at the end by itself, or repeat this thing 3 times with a little thingy like at the beginning by itself. Okay. And so these things can be pretty challenging. Okay. Now let's look at another way that this stuff can become challenging. So let me do another kind of nested for loop. Okay. Here's what I want the output to look like. I want the output to look like this. I'm going to put a comment down here with what I want the output to look like. I want to print out the number 1, then 1, 2, then 1, 2, 3, then 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, I want to do that. I want this little triangle of numbers. Okay. That's a nested for loop, but it's not a table. It's kind of like, if you think of it, it's half of a table. Yeah, in a sense, there's another part of that table missing. If I want, there's a part of that table that's missing that I'm not going to print out. Okay, so I'm going to print out, no, there is a square, there's a table there, but I'm only going to print out the 1, 1, 2, 1, 2, 3. Okay, I don't want to print out this part. I don't want that to be in my output. So I'm going to delete it. I don't want it to be there. Okay, so this is nested for loops. The outer loop is going to still be the rows. So let me say I know how many rows there are. Int rows equal this one. I can't see. I had 1, 2, 3, 4, 5, 6 rows. And in a sense, I have columns, but I'm not sure if I need it. I'm not really sure yet whether I need a variable for columns, because I don't use it. Here I only have 1 column. Here I have 2 columns. Here I have 3 columns. Here I have 4 columns. I end up with a total of 6 columns, but only in the last row. So let me not pick a variable for columns, because it doesn't seem like I'm not sure I'm going to need it. I do need to count how many rows there are. Okay. Then I will have for int I equal 1. My outer loop's going to pick rows. It's going to just be like, I'm going to think of it like as if it was a table. So the outer loop is going to do the rows. For I equals 1, I less than or equal to rows. Okay. I plus plus. And then in here, I want to do 1 row. Okay. So in here, I want to do 1 row. So real quick, I can finish this. Now, this is the row. This goes across the row. For int j equal 1, j less than. Now, here is where I would usually say columns. But how many columns are there? In the first row, there's 1 column. In the second row, there's 2 columns. In row 3, there are 3 columns. In row 4, there are 4 columns. In row 5, there are 5 columns. In row J, well, I'm in row I. See, I is what row I'm in. In row I, there are I columns. J plus plus. Go to the next row. Go to J plus plus. Go to the next column. Okay. In this row, I'm in the ith row. In that row, there are that many columns. Okay. Let's just finish it real quick because we're out of time. So what do? I just print out the number. System dot out dot. Well, what number am I printing? Column 1, column 1, column 2, column 1, column 2, column 3, column 1, column 2. I'm printing out the column counter, which is J. Okay. Now, when I get to the end of a row, I need to go back to the beginning of the next row. Now let's see. Okay. Oh, I didn't do something right. What did I do wrong? Please, anyway. So what did I do wrong? I did something kind of goofy. What did I do wrong? I got 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. What's the, I made some silly little mistake. What was it? How did I get everything in, everything's in one column. What forced everything to be in one column? Yeah, I printed out a line there. Okay, so there's my output that I wanted. Okay, so triangular patterns are now tables, or they're nested for loops. So this is what we'll pick up on Thursday. We'll do lots more of these we'll do a lot more different patterns. We'll see there's lots of patterns we can do with nested for loops. So I can do this triangular, which is half of the table, but then there's other halves of the table. Like, what about if I wanted to do that one? We'll do that. Okay. There's other examples we could do. We'll do this one. This is a tricky one. That's going to be a tricky one. We'll do that one. We just did this one. This one's pretty easy, almost as easy as this one. This one's harder. When we get to that one's going to be a tricky one. That one's harder. Okay, so let's quit there. Anybody got any question? Any last question about nested for loops? What we've done so far? Go back and read the section on nested for loops, and we'll do and look at these examples. These examples are harder than they might think. This is harder than you might think from what we just watched. When somebody starts giving you patterns and saying, write the loops that do them, they can get to be pretty challenging. Okay, like I was saying, we'll see how to do this one. This one turns out to be quite a bit harder than these two. And I can do all kinds of there's endless supply of patterns, and we'll do a lot of them. Somebody just gives you a pattern and says, write the for loops that draw this pattern. They're very challenging problems. Okay, so we'll do a bunch more examples of this on Thursday. Anybody
I got a question.
Yeah,
So what would be like the most applied cases for these nested for loops like this?
Oh,
like
tables.
In the real world,
Tables.
Tables. Oh, okay. You said it
Oh
earlier.
boy,
Right?
yeah. Have you ever noticed how many people? What is the most used computer program in the world? Does anybody know?
Is it Excel?
Yes. Yep. Yep.
Oh, wow.
Excel is just unbelievably. It's the most used programming language in existence. You think that C++ or Java, and it turns out no. Excel. Tables. Yeah. Yeah.
Okay.
Yeah. Processing tables, reading tables, printing tables, computing from tables. Yeah. Now that's not the only way we use nested for loops, but boy, is it a common way. Tables are everywhere. Data is everywhere, and data comes in tables pretty often. Okay.
Thank
And
you.
string. And another thing we'll see is strings. Working with strings can be done with nested for loops. Okay, we'll do some examples with strings where you use nested for loops to work with a string. Okay, but think tables. Almost everybody teaches nested for loops just using tables to get you started with them. Okay, any other question before we quit? Okay, so we'll meet on. Oh, and remember, look for your exam. I'm pretty sure this evening I can get the exam scores up there, and not just your scores, but look for the exam itself. Please make sure you look at your exam to see what I wrote on it. Okay, so we'll stop there and meet again on Thursday.
you.
Bye-bye.